All right, so now let's talk about actual types of experiments and specifically the characteristics of the experiments first. So, an experiment is a controlled study conducted to determine the effect of varying one or more explanatory variables or factors, right? Um, that will have on a response variable. So we've already talked about this, right? It's explanatory variables explain the response variable. So an experiment is just trying to see if that's true or not. Any combination of values of the factors is called a treatment. The experimental unit, also known as the subject. So subject is probably what you've heard before, a subject of an experiment, but another way to say that would be the experimental unit is a person, object, or some other well-defined item upon which a treatment is applied. These are all the people, things, other items that we're looking at. So most of us probably know what most of this stuff is, right? Control group. So you don't need to know specifically the words, but you probably have a good idea of what it is. It serves as a baseline treatment that can be used to compare to other treatments. The reason why we have a control group is to compare it to some other treatments to see if it actually does work. A placebo is an innocuous medication, such as a sugar tablet, that looks, tastes, and smells like the experimental medicine or medication. So a lot of the times, the control group is going to be given a placebo. Placebos don't do anything. So sometimes a psychological component can be involved when it comes to feeling better. So that's why we give people placebos. Blinding is referred to as the non-disclosure of the treatment of an experimental unit is receiving. So a single blind study is when the experimental unit doesn't know what he or she is getting. A double-blind study would be when the experimental unit and the researcher doesn't know which is receiving. So again, because of this psychological component, the reason why single-blind studies are used, why the subjects or the experimental units should not know what's going on is because if you know you're getting medication, you might feel like you're getting better. And specifically, if you know you're getting a placebo, you might just subconsciously think, oh, well, they're not, I'm not going to get any better from this. This isn't helping me. Likewise, if the researcher knows that the subject may have the actual medication, he or she may actually be more prone to say, oh, well, they look a lot better, as opposed to if they had placebo, they'd be, oh, well, they're not looking as great, right? So that's why double-blind studies sometimes are what we want to do. And then we got replication. So replication is the process of assigning several experimental units or subjects to each treatment. It helps to show that observed effects are not due to some single characteristic for some single experimental unit, but it's actually due to the treatment. So you want to do the process of experimentation over and over and over with many different experimental units or many different types of subjects, because it could just be like genetics, right? A single subject might be getting some good effects, not because of the treatment, but just because that's just how their body is wired. So you want to make sure to look at several different experimental units to see if it is the treatment or not. All right, let's talk about some types of experimental designs. So we're going to talk about these, and then we're going to look at a couple of examples, and then we'll be done with this video. A completely randomized design is one in which the subject or the experimental unit is randomly assigned to a treatment. The matched pairs design is an experimental design in which the subjects are paired up. Makes sense, right? Matched pairs, they're paired up. So they're paired in such a way where they are related to each other. So this could be husband and wife, right? There's two groups. One's the husband, the other one's the wife. It could be twins. It could be people who live in the same geographical location. So you pick two people from each location. It could also be the same person before and after a treatment. So we could be comparing one person's body before treatment and after the treatment. And that would technically be a matched pair. All right, a randomized block design are going to be one where the experimenter divides the participants into blocks. Or subgroups, excuse me, called blocks. So this is the type of pre-made groups that we've talked about. All right, so this would be using a cluster or stratified method, probably. And the way that these blocks will work, the variability within the blocks is less than the variability between the blocks. So if you separate people into genders, right, there should be less differences between people of the same gender than people with different genders. You could also talk about ethnicities, right? You would see that there's more characteristics within the same ethnicity than between different ethnicities in this scenario. So that's what these pre-made groups are. So if you understood the idea of those pre-made groups in one of the previous videos, then this should be okay too. And then participants in each block are randomly assigned a treatment. All right, so now we have a cross-sectional study. So this is an observational study that affects the person at a specific point in time, or over a very short period of time. I can tell you, this is the way that I think about this one. This is the present study. Present as in the here and now study. The next one is the case control study. So this is a retrospective. Retro means past, right? So meaning that it requires individuals to look back in time, or require a researcher to look at existing records. So in these types of studies, individuals who have certain characteristics may be matched with those who don't. So just like how we said, I like to think of the cross-sectional study as the present study. A case control study would be the past study. And if you can see where we're going, right, the cohort study should be the future study. So a cohort study is a prospective. So pro means forward, meaning that it requires observing and recording characteristics about an individual group known as a cohort over a period of time. So for instance, a lot of nursing students or medical students you'll hear are in cohorts. This is essentially their class, right? So first year, second years, third years, and they're kind of together throughout their time in school over that period of time. All right, so we talked about a lot of stuff. Let's actually put all these definitions together. So we only have one problem, 4 parts to it. So for each of these, we ask ourselves 5 questions. What's the experimental design? What is the population being studied? What's the response variable? What are the treatments? And what are the experimental units? All right, part A. Xylitol has proven effective in preventing dental caries or cavities, when included in food or gum. A total of 75 Peruvian children were given milk with and without the drug and were asked to evaluate the taste of each. The researchers measured the children's ratings of the 2 types of milk. All right, so some of these might be easier to identify than others. So let's look at the population first. Maybe that would be the easier one. So number 2, population. What is the population in this case? So a lot of people would be tempted to say that it is the 75 Peruvian children. But is that every single person that they're trying to look at? No, right? The 75 Peruvian children are actually, that's the sample of children that they're looking at, which would mean that these are all of the subjects. These are the experimental units. So this is part 5, the 75 Peruvian children. So if your sample consists of 75 Peruvian children, what would be your population? Well, remember, population is everybody. So this is all Peruvian children. All right. So we got part 1, we got part 5. Let's look at part 4. That'd be another easy one. So what are the treatments in this case? Where are we giving the children? Well, we can see we're giving them milk with and without the xylitol. All right. What is the response variable? So what are we actually trying to measure? So some people might think, oh, well, supposedly the drug prevents cavities, so that's what we're trying to measure. But if you notice, that's not what the researchers actually measure, right? What do the researchers measure? They measure the children's ratings of the 2. So what they're actually measuring is whether one can taste the drug. Or you could write something like the likability. Likability. Yeah, that's probably how you spell it. Of the xylitol milk. Right? They're trying to see if children would actually, if they put this in milk, would children actually drink it? All right. And so last one. What type of experimental design is this? Okay. Or what is it not? So let's go through this. So it may be completely randomized. So let's not rule that one out. It may be matched pairs. Let's look at this. So it's definitely not a random block, right? Why? Because there's no subgroups here, right? It's just 75 Peruvian children, and that's it. All right. It's definitely not a case control study. We're not looking back in the past. It's not a cohort study. We're not doing anything in the future. It might be a cross-sectional study, but maybe there's a better explanation. So let's think about matched pairs, right? So matched pairs pair people off or pair the same person before and after treatment. So can you see that in this case, it's actually a matched pairs design, right? So the question would be, what are the pairs? So it's going to be closer to this, right? So it's the same person with the Xylon milk, or xylitol milk, and without the xylitol milk. So the same person or the same child is comparing two different things. So they're their own matched pair, as it were. Yeah. So number one, this is a matched pairs design. All right, let's do part B. Researchers at the National Center Institute studied meat consumption and its relationship to mortality. Approximately 500,000 people were surveyed, and they were followed then for a period of 10 years. So again, population probably be the easiest to figure out. Population or the experimental units. Right? So which one is which? So we see that they approximately looked at 500,000 people. So is that going to be our population, or is that going to be experimental units? So that's just in our sample. So that's going to be the experimental units, 500,000. So then what's the population going to be? So it's going to be all of it. And since we're studying meat consumption, it's just going to be all meat eaters. All right. So next we can talk about the response variable. So what is the response variable this time? What are they trying to figure out? Well, they're trying to see the relationship of mortality, and they follow them over a period of 10 years. So really, they're trying to measure whether death occurred, right? You could also say the mortality rate. All right. Treatment. What's the treatment here? So some people might say meat, right? That they treated with meat, but did they? No, they actually didn't, right? They didn't give these people meat. These people just ate meat, and they recorded mortality. So what did they give them? They actually didn't give them anything, right? Because if you look at another type of study, this is actually an observational study. Right? This isn't an experiment at all. And remember, observational studies don't have treatments. Aha, that was a trick. Gotcha. Or maybe not. Maybe you got me. And then lastly, all right, so what type of design is this? What type of experiment or observational study is this? So, because it's an observational study. So, we're looking at people, and then we're following them over a period of 10 years. So that sounds like a future one, right? Future study. So that would be the cohort study. All right. Part C. An octane of fuel is a measure of its resistance to detonation, with a higher number indicating higher resistance. An engineer wants to know whether a level of octane in gas affects the gas mileage of an automobile. So she randomly assigns 4 cars to the 87 octane, 4 cars to the 89 octane, and 4 cars to the 92 octane. She then gives each car 3 gallons of gasoline, and drivers of the car, or she gives each car 4 gallons of gasoline, drives the cars until they run out of gas, and then computes the gas mileage. All right. So, first things are easiest: population and the experimental units. So, what is the experimental units this time? we can see, right, 4 cars, 4 cars, and 4 cars. So it would just be 12 cars, which means the population would be all cars. Good. Or maybe all cars with gasoline. So obviously this wouldn't be cars with diesel or electricity, right? Or garbage or something. Yeah, so if you notice, these numbers might look familiar because these are the ones that we see at the gas station, right? Most of us will see. So that's just all this is. This is the regular, the Supreme, and the premium, something like that. Good. All right. What is the treatment? That's pretty easy, right? It's the 87, the 89, and the 92 octane gas. What's the response variable? What are we trying to measure? So the whole thing is computing miles per gallon, right? So we're trying to figure out whether the level of octane affects what? Gas mileage, right? If we're comparing different types of octane and then computing their miles per gallon, we're trying to see, does different octanes affect gas mileage? All right, so last one. We got to talk about our design. What kind of design experiment is this? So let's go back through all of them. So definitely not matched pairs, right? There's more than one thing going on here, or there's more than 2 things going on, so it's not going to be matched pairs. It's not going to be the case control study, right? Because we're not looking in the past. We're not looking in the future, so it's not the cohort. So let's think about this. Would it be the block design? So some of y'all might be tempted to say block design, but let's look at this. Remember the blocks, because I would then ask you, well, what are the blocks? Some people might say, oh, well, the blocks are the 87, the 89, and the 92. But remember, these are blocks that are in pre-made groups, right? So that, and remember, the variability within the blocks needs to be different than between the blocks. So these 4 cars with 84 are not any different than these 4 cars with the 89 or these 4 cars with the 92, right? There's no difference between the cars. This car is not an 87 car, right? This car is not a 92 car. We are the ones that assign the groups. These are not part of the pre-made groups. Does that make sense, hopefully? So because of that, this is not a block design. We're the ones that put them into groups. They didn't come in groups, right? Now, if we made, separated out them by makes, right? We put Ford cars in one, and we put Toyota cars in one, and we put Saturn cars in one. I don't really know cars, so if these are similar, just forgive me. But if we separate them out like that, that could be a block design. But since we didn't do that, right, we just put cars with different numbers of octane, this can't be a block design. So really the only thing we got left is a cross-sectional study or a completely designed experiment. So in this case, we can just say it's a completely designed experiment. Because it's not an observational study, right? Yeah. That cross-sectional is only for observational studies. This is an actual experiment, right? We have a treatment. We know that we're dealing with a completely randomized design. So, completely randomized design also is going to be the easiest one to cancel everything else out. So, if you think it's completely randomized, make sure it's not anything else. That's going to be the best way to say that it is completely randomized. Last problem. For this design, participants are randomly assigned to treatments of the drug Lipitor. Since men and women are physiologically different and react differently to medication, participants are separated by gender, where 250 men get the placebo, 250 men get the drug, 250 women get the placebo, 250 women get the drug. All right. So, first of all, what is the population? What is the experimental units? So we can see the experimental units. We have 250 men getting a placebo, 250 men getting the drug. So 250 plus 250, we see we have 500 men. So 500 men. And same thing, right? 250 women getting the placebo, 250 women getting the drug. So we also have 500 women. Or you could just say 1,000 people, right? Either way. So what would the population be? If we have 1,000 people in our experimental units, then the population would just be all people. Good. What's the treatment? So we can see it's the placebo and the drug, Lipitor. What's the response variable? Well, arguably, it'd be to see if Lipitor works. So whatever Lipitor is supposed to do, it's to see the effectiveness of the drug. All right. And lastly, what is the design of this experiment? So some people might say, oh, well, it says randomly assigned, so this must be the completely randomized one, right? But what did we say? If you think it's a randomized design, or completely randomized, you need to make sure it's not anything else. So first off, we have a treatment, so it can't be an observational study. So the last four, or the last three, these were all observational studies, right? So it's not going to be the cohort. We're not looking in the future. It's not going to be the case control. We're not looking in the past. And it's not going to be the cross-sectional, because we ain't looking at an observational study. All right, so then what we got left is matched pairs, random block design. All right, so if we have matched pairs, how are we comparing these two different things? So some people may think that it's we're comparing men with placebo and men without the placebo, right? So with the drug. And we're comparing women with the placebo and women to the drug. But this is more than two, right? We're separating people into men and women. So this can't be the matched pairs. That's more than two groups. All right, what about the randomized block design? Hopefully you've gathered by this point that this is actually what we're looking at, right? Because what would be these blocks? What are the pre-made groups? It's gender, right? We separate people out into men and women. So making it simple on us, just separating people out into men and women. And then we assign, right? Participants within each block is then assigned a treatment. So men got placebo, men got the treatment. Women got placebo, women got the treatment or the drug. Right? So this is definition randomized block design. All right. So that was it. As always, if you have any questions, feel free to contact me.